In the previous session, we tried understanding what is logical operators. In this session, we'll try to understand what is short circuit logical operators. So Java supports two types of logical operators. One is non-short circuit logical operators. Second is short circuit logical operators. So the general default logical operators, whatever we have used, they're called short circuit logical operators. So what do you mean by that? And then what is non-short circuit logical operators, we'll see. Let us learn them programmatically.
Hey, thanks for watching our content so far. If you're new to Training Mark, we're the fastest growing technology training company and create content to help freshers like you to master the disruptive technologies like full stack development, AML, cloud, DevOps, etc. If you like the content so far, please subscribe to our channel and hit the bell icon not to miss any new content from us. Like and share this video with all your friends. Let's build your career and the community together.
To demonstrate that, let us see the logical operators program. So what we have used is, these are called short circuit logical operators. So what do you mean by that short circuit logical operators is, let us take this with a simple example. Okay, so now I'm calling this as short circuit logical operators. So what do you mean by that is, suppose I'm taking very simple example here just to demonstrate. So I'll say byte number 1 comma number 2. I'll say number 1 is 10 and number 2 is 20. Okay, so now I'm just using a out, right? Guys, just closely observe what I'm doing. Number 1 plus plus, I'm just incrementing this, and then greater than 10. Okay, so this is true. Basically I'm just using logical and number 2 minus minus, I'm decrementing this, less than 15 or something like that. Okay, now let us see, or maybe I'll just give it as 25 just to make it true. Okay, now let us see what basically happens is, number 1 is 10, which we are incrementing it, it will become 11. 11 greater than 10, this is true, right? This condition is true. Logical and coming to this here, number 2 minus minus, so 19 less than 25, basically they both are evaluated true. But whatever we are using here, these two ampersands are basically called a short circuit logical operator. What does it mean is, according to logical and, if one of the expression is evaluated to true, one of the evaluation is expected to false, then the entire resultant is false. Example, if the first one is evaluated to false, do I need to evaluate the second one? I don't need, because this is already evaluated to false. Then by default logical AND will give the entire resultant as false. So in this case, this short circuit logical AND will not evaluate the second one. So that is what basically happens here. So now what I do here, the number 1 instead here I'll just make it false. Okay, now let us understand what basically do. Number 1 plus plus, now this is now 11 greater than 20, so this is false. When this is false, what your logical AND will do, this is short circuit, so it will cut the operation here itself. It don't even evaluate the second expression. So in this case, the number 2 will not be decremented, number 2 will be as it is. So now what I do, so there is no change in the evaluation, so the resultant is going to be false. Now let me print number 1 and then let me print number 2. So basically what I need to get here, so if both of these are evaluated, number 1 will become 11 and number 2 will become 19. But let us see what is the output that we'll get. So let me run this to see what is the output that we'll get. Guys, you can see here, so what I got, number 1 is 11, so means this is evaluated, but number 2 is not evaluated. Now you can see this condition is not evaluated. Why? Because this is false, so it won't evaluate. Suppose if I give this 10, now what basically happens now? This is true. So when this is true, it cannot take a call because it has to evaluate this one also. Now this will go and then evaluate this. Okay, because the first resultant is false. So whenever the resultant is false, first resultant is true. Whenever the resultant is false, it will just stop the execution there itself. So now let me run this. Now in this case, both of them will be evaluated. Now this is false. Okay, now this is true, and this is logical AND. Okay, let me save this and run this. Okay, so now this is true. This is post arithmetic operation. That's the reason 10 greater than 10 it will become false, right? So now what we do here, I will just increment it something like this, plus plus number 1. Hope you understood why it is coming false, because that is post increment. Now I am doing pre increment. So now this will become 11 greater than 10. So what basically it will do is so now 11 greater than 10 is true, so then definitely it will go here. So then this will become false, because number 2, 20 less than 25, this is false, because here also we are using post decrement. So number 2 less than 25, so this will become 20 less than 25, which is false, and after that number 2 will be decremented, so it will become 19. So that is the difference between pre and post, which you have already seen in our previous examples. So now let me run this to see what actually happens. Now you see this is true, right? Number 2, which is 20 less than 25 is true. So that's what I got. This is true, this is true, so the resultant is true. And if you can see that number 1 is 11 and number 2 is 19. So we got it like this. Suppose I'll just change this to 15. Now what basically this will give now? This is false, this is true. So the resultant is false, and this should be 11 and this should be decremented. So number 2 will become 19. So let me run this just to see what is the output. So now here false, 11 and then 19. So this is what is basically how short circuit logical operator will work. Now the same thing will be true in case of logical and short circuit logical AND. So what is short circuit logical AND? Logical OR. The logical OR, if any one of the expression is true, then the entire resultant is true. Means what? If the first expression is evaluated to true, it won't even evaluate the other one, because by default it is going to be true only. So that's why. So what I do here, I'm just reinitializing this number 1 is equal to 10, and then number 2 is equal to 20, right? So now in this case, what basically happens is I'm just going to execute the same thing, and we will see with a logical or short circuit logical OR, and then I'll change this to non-short circuit, and then I'll explain how it will work. So now in this case, what is basically this will be? So now 11 greater than 10, this is true. So when this is true, it won't even evaluate this, right? It doesn't even matter whether this is true or false. So now in this case, what should I get? So now when I do, this is logical OR, so it doesn't even care and evaluate this one. So now let me print these two values after this and see what is the output that I'll get. So in this case, what I need to get, here I'll get 11 and here I'll get 19, and then the resultant is true. So let me run this. Now you see true we got, because this is true, so it won't even evaluate. But if you can look at this, number 1 is 11 and then number 2 is 20 only. Why? Because it is not at all decremented this value, right? Now if you want to evaluate this, definitely what you do, you have to give this a short circuit. So what do you mean by non-short circuit? What do you mean by non-short circuit? We'll say that, hey, don't mind whether it is true or false, you have to evaluate the second one. So then the non-short circuit will evaluate every expression irrespective of whether it is true or false. So in this case, what basically happens, it is not going to change the resultant, because the resultant is going to be same. This is true, this is false, and then the resultant is true only, and number 1 will be 11, but number 2 now will be 19 in this case. So now let me run this. So now this is what is a short circuit and then non-short circuit. So we don't have non-short circuit in XR, because XR will evaluate both the expressions to find out whether true or false. So only in logical AND and then logical OR. So in the logical AND, if you want to use non-short circuit, you have to use something like this. So now if the first expression is false, right, suppose it won't even evaluate the second one. So in this case, let us say number 1 plus plus is greater than 10, this is true, or let us make this as false. So now in this case, this is false and this is true. So but what basically happens, this is false and number 1 is going to be 11, but number 2 is 20 only. But if I do non-short circuit, right, so now I'm just going to add this as non-short circuit to see the output first. So this is the short circuit. So now if you can see this, the short circuit we got false, right? This is what is a false, and we got 11, and then this what we got is 20, because this is not even evaluated. But when I change this to non-short circuit, means what? It will evaluate both the expressions, where number 1 is going to be 10, and then number 1 is incremented, this will be 11, and number 2 will be decremented, and it will become 19. So the same resultant, but to evaluate the other expressions or not, we'll use short circuit or non-short circuit. So if it is a short circuit, we'll use 2 ampersands, and if it is non-short circuit, we'll use single ampersand. Same in logical OR, we use 2 pipe symbols for short circuit logical OR and 1 pipe symbol for non-short circuit logical OR. So these kind of questions will get in certification or interview questions. So don't get confused. This is also legal, and it is called as non-short circuit logical AND and non-short circuit logical OR.